I'm proud to announce our first speaker, Dr. Svenja Kloss. She holds a master degree in chemistry, obtained her PhD in chemistry at the Leibniz Institute for Catalysis, and now is research group leader at the Sustainable Packaging Institute. And I'm already really curious to learn more about intelligent packaging concepts in general. Svenja, it's your floor. Thank you.
Thank you very much, Professor Schmid, for the kind introduction to my talk today about intelligent packaging concepts and how intelligent packaging can reduce food waste. And first of all, I want to just briefly introduce you to my talk and what I want to talk about today in the time that I have today. First, I want to introduce the Sustainable Packaging Institute, which is also the institute that Professor Schmid is the head of. Afterwards, I just want to briefly address the topics of food waste and smart packaging in general, and want to dive a little bit deeper into detail in the main field of intelligent packaging systems in the food industry. After this, I want to briefly introduce to you the project Smart Material that we are currently working on at the Albstadt-Sigmaringen University. And last but not least, I want to give you a brief summary of all the things that I talked about today. So first of all, the sustainable packaging is located in Sigmaringen. And if you are not really familiar where this is located, it's roughly between halfway between Stuttgart and the Lake of Constance. And besides a quite beautiful castle, I would say, there's also the Modellfabrik, or the Innovation Campus Sigmaringen, located, where also the sustainable packaging is located and where we are working in quite modern laboratories, own our own model factory. There's also academy and an ITZ located there. And the Sustainable Packaging Institute teaches and researches in 6 thematic areas that I want to address a little bit further in a minute. And also the Institute researches, or the research focus is on sustainable packaging concepts. It is our mission to support all players in the packaging industry along the entire value chain, in the life science industry on their way to a more sustainable, circular bioeconomy, completely and holistically. And this we want to do in 6 research fields, as I already said a moment ago. And these research fields contain, for once, the biogenic raw materials, also process technology and process design, the functional materials, smart packaging, which could be divided into active and intelligent packaging, preservation and packaging, and also bioeconomy, sustainability, and therefore concepts, assessment, and perception. If you want to know further about the Sustainable Packaging Institute, don't hesitate to ask further questions after my talk, or even to Professor Markus Schmid after this session. We are proud to tell you a little bit more about all the other research fields today. But where I want to mainly focus today, as I said already, on smart packaging and intelligent packaging. But to give an introduction into this topic and why this could be an interesting topic about the reduction of food waste, I just first want to talk a little bit about food loss in general. First of all, I think it is a very interesting number to hear that about 18 million tons annually alone in Germany of food is lost. And about 10 million tons of this food loss could have been avoided. And we all think this is a main problem, depending on the resources that go into food and food production. And so we want to ask ourselves, how can we reduce this number? And if we look a little bit further into the shares where main food loss does occur, we see, at least depending on this survey taken in 2019, that a main share is produced at the consumer stage, with 39% and almost 7.23 million tons of food loss, which is a lot bigger than all the other shares in this surveys show. And also the percentage of avoidable food loss is extremely high at the consumer stage. What could be the reasons for this observation? Maybe it's wrong shopping behavior of the consumer, wrong storage of the food, wrong interpretation of the expiration date, which is printed on the packaging, leftovers from food, like cooked food, that goes to the trash, and also maybe low appreciation of food. But we can look at these reasons a little bit further, also depending on this survey from 2019, where we see that the consumer states that main reasons are wrong quantity planning shopping with 12% and portion planned too large with 21% could be main reasons for the food loss at this stage. But the very first and most important reasons for the disposal of usable food is the shelf life, and especially the interpretation of the shelf life by the consumer, with 58%. And especially this point we want to address with smart packaging. Also with active packaging, but also with intelligent packaging. And so, just to give you a brief introduction into this topic, what smart packaging is and what it contains, I want to tell you just some brief definitions and some brief informations. First of all, smart packaging contains on the one side the active packaging and intelligent packaging on the other side. And active packaging, on the one hand, rather addresses product protection and is defined as materials and objects that are intended to extend the shelf life of a packaged food or to maintain or improve its conditions. And it could contain release systems and absorbance scavengers. And intelligent packaging, on the other side, is rather an addition to the communication function of traditional food packaging and is defined as materials and objects used to monitor the condition of a packaged food or the environment surrounding the food. And intelligent packaging can contain sensors, indicators, and data carriers, which I will further introduce to you in a few slides. But first of all, a little bit more information about intelligent packaging in general. As I already said, it's an extension of the communication function of traditional food packaging. It is used to ensure the product integrity, improve the user experience, and also to optimize the supply chain, which I also further address later a little bit. It is used to recognize, register, and record changes in the product environment and the product properties along the whole supply chain. And therefore, it can also increase the product safety, give some more information about the spoilage processes, and also information or rather additional tool for the falsification. It can give an actual product quality statement about the packaged food, which I will further address in a few slides, and can therefore be a support for the consumer decision. And it enables mathematical models to produce or enable forecasting algorithms, which can be used to give a dynamic expiration date, not the usual expiration date that we know from packaging today that is printed when the food is packed, but also something that is maybe obtained by an app or something that you already know depending on the packaging conditions, for example, when the food might be spoiled. But what are the main requirements for intelligent packaging? And what do we have to think about when we want to obtain or get such an intelligent packaging system? First of all, the measurement principle, so the indicator or device that we are adding to the packaging should have an activation energy similar to the spoilage process of the food that we have packed into, and should have the same endpoint and be highly specific for the spoilage process. This should be in correlation between real quality changes in the contents, so the food, and the information of the intelligent packaging. And therefore, we use the calibration using the reaction kinetics of the spoilage processes, for example, but also of the indicator materials. We also need defined values for the quality assessment and a clear statement for the intelligent packaging. For example, that the dot that we see here clearly changes its color when the food that is packed is spoiled and should not be eaten anymore. I think in this example, it also could have been a little bit clearer what kind of orange, for example, the package should show, so that the consumer directly knows if the food is spoiled or not. Intelligent packaging also has to be conform to food. As everything that is in contact with food, there are a lot of regulations. And ideally, the ideal system should be recyclable and economic to be accepted by the consumer. For intelligent packaging, there are three main groups of systems that we can use, and these are the sensors, indicators, and data carriers. They are usually used for either the measurement of quality-specific lead substances during the spoilage process. They can also be used as proof of packaging integrity, for example, if there are leaks in the packaging, and also to monitor the environmental condition, for example, the temperature. The first main group are the data carriers, and they are usually the broadest already used system known from the supermarket today. They're used for the storage and also for the transmission of information, and we usually use holograms, these barcodes that everyone knows of us, and also RFID chips. And they can be used to localize and track the packaged food for the authenticity, and also as anti-theft device. These data carriers also offer the opportunity to give extended packaging information. For example, over online information sites, or also over applications on the mobile phone, so the consumer can retrieve further information, so for example, about smartphone, and this can improve the user experience. Also, this gives them opportunity for further additional functions. For example, the reminder regarding expiration date and for a forecast of remaining shelf life. For example, when you scan your product, when you buy it and put it into your fridge, you can scan it, and then an app will tell you, okay, in 3 days, this food that you bought 5 weeks ago or so will likely be expired. Maybe take a look if you can use this in the main days. The second big groups of intelligent packaging concepts that we use are the sensors. And sensors are components that convert a measured physical quantity or biochemical effect into an electrical, optical, or thermal signal. And these can further be divided into the biosensors and gas sensors just in general. I just want to give you just some brief information about all these topics and what possibilities are there for us in the future in this field of intelligent packaging. And biosensors, for example, work on immobilized biological active systems, and the gas sensors, for example, are used for the detection of oxygen, of carbon dioxide, of volatile metabolic products that arise during the spoilage processes, for example, and show about this electric signal that the food might be spoiled. And the last big group of these systems are the indicators, and these are defined as labels with visually recognizable color change. And there are also a few subsections of the system. For example, the temperature indicators, which are also known as partial history indicators. And these react at a certain temperature threshold is reached, either or fallen below, and this shows, okay, this food might have been in the car in the summer, heated over 40 degrees, and so the spoilage process might be further than expected. Another group are the time temperature indicators, or partial or full history indicators, and these are usually used for refrigerated and frozen meats, for example, and they register the temperature curve continuously. I don't want to go into specifics here because we will hear a talk later of Ms. Kleinschmidt that will talk a little bit about TTIs in detail and the project that they are working on. So I will just leave this information like it is. Another possibilities for this specific kind of indicators are gas indicator systems, or also oxygen indicators, which are a subgroup of this kind of indicator. And they usually show or are used to the validation of the gaseous atmosphere that is contained in the packaging. If you think about your meat packaging, for example, this is usually packed under modified atmosphere packaging, and these indicators can show if there are leaks, for example, in the packaging that lead to too high or too low oxygen levels, for example. And the last big group are the freshness indicators, which are used to monitor the product quality along the supply chain. And they're used for the real detection of spoilage products, for example. Volatile metabolites, which are produced during the spoilage reaction. These could be organic acids, CO2, biogenic amines, and so on and so on. And these are a very interesting group that we are also currently working on at our project Smart Materials, that I just want to briefly introduce to you, as it is a very interesting topic that is really currently worked on in academic research. And this is a shared project together with another work group at the Sigmaringen University, using, on the one hand, intelligent textiles and functionalized textiles, and also, on the other hand, the intelligent packaging. And our aim is to develop a smart chemical and temperature and humidity switchable functional and indicational layer of technical textiles and intelligent packaging. The project management, therefore, is performed by Professor Jörn Löwen and also Professor Markus Schmid. And it is planned for a 3-year period and is funded by the Carl Zeiss Foundation with a rather generous budget of €1 million. And because of this shared project together with the intelligent textiles, we are hoping for synergetic effects by merging these two projects. In the part of the intelligent packaging, we first want to identify spoilage products, especially for the freshness of meat and sausage products, and then further identify indicator systems like freshness indicators, as I already said in a few slides ago, and evaluate and select them and apply them into smart packaging to obtain a color change depending really on the freshness of the packaged meat and sausage products. And we want to integrate this into the smart packaging systems, which is also based on renewable raw materials and biogenerated polymers. And of course, we have to validate this product in the end. Yeah, and in the end, as I already said, with the combination of the smart textiles, we want to get a material efficient coating on the textiles with our indicator materials to obtain 3D structures, and hopefully we therefore also get cost reduction of the finished intelligent packaging concept. Yeah, in the end, I just want to briefly summarize all the topics that I quickly addressed in this talk. And this is, for instance, that intelligent packaging can contribute to increase the product safety, as I hopefully could show you, by stating a clear statement about the quality of the packaged food. It also helps to prevent falsifications, and also, hopefully, in the end, it can also reduce food loss, which we honestly have to say has to be proven in the future. There are different options available currently, which are sensors, indicators, and data carriers, and they can be applied along the whole supply chain. And there are some important requirements that have to be met. For once, the correlation with the actual quality change, depending also on the packaging and the storage conditions. It has to give a clear statement, as I already said. The cost-benefit ratio has to be good. The consumer acceptance has to be met. The recyclability would be a benefit, and also legal requirements have to be met, obviously. With this, I want to close my talk for today. I'm now open for your questions, if there are any today, or even though also after this session, or over the given contact information here on the slides. Thank you very much for your attention.
Thank you very much, Svenja, for this great talk. And I would like now to open the question and answer session. So please feel free to raise your hand if you have a question or some remarks. And as we are not using microphones for you, I will simply repeat your question then, in order to make it understandable for everyone. Any questions? Oh, no, no. Oh, we have one question. Very good.
We have numbers on avoidable food waste. How is avoidable defined?
Okay. Svenja, I repeat the question, and for everyone, there were numbers for avoidable food waste. How is avoidable food waste defined?
As this was a survey, the definition was rather, it was taken to account that avoidable food waste, at least at the consumer stage, is at most stages, food that could have been used, but is not was thrown away by the consumer because maybe the expectations were not met. So this food was not spoiled, but it was also thrown away. So this is a general definition. As it was a survey, that we could not prove that the spoilage process was already taken to a certain level.
Thank you, Svenja, and thanks for the question.